7.6, the inverse of a square matrix. These are the objectives. You can pause to read. I am moving on to the next slide. Vocabulary key concepts. Again, pause to read. I am moving on to the next slide. I just want you to watch this. You don't have to copy this. You need to solve the system. Now, every single one of you should be able to how we get this using, excuse me, the algebraic techniques you learned in Algebra 1. Now, I want you just to follow this. Notice where I'm getting this matrix A. I'm just taking the augmented of the left side of this linear system. Where do I get 7.5? The right side of the system. Where do I get this C from? You'll see in a little bit how we can find the C. But this is what I'm going to do. I'm going to multiply C times A, and this is what I get, which is the identity matrix. Now I am going to multiply C times B. Take the product of these two matrices, and this is what I get. Notice that this is a solution to the linear system. And you'll see why I'm showing you this as we go along on this video. Next slide. So here's number 1. It says find the inverse of the matrix. These are the steps that you take to find the inverse of this matrix, or any matrix. Actually, I shouldn't say any matrix. Not all matrices have inverses, but the ones that we're going to be doing here, they do have inverse. So notice that I copied just the 2 by 2 matrix, and right next to it I put the identity matrix. So my goal is to do the following. I'm going to rewrite this matrix, and what I'm going to do is I'm going to make this the identity matrix, the matrix that you see on the left hand side. So I'm going to be doing operations to make this identity, and something's going to happen with this matrix on the right hand side. And you'll see that in just a little bit. So I'm going to multiply -3 times row 1 and add it to row 2. When I do that, this will go away. And notice then something begins to happen with the identity matrix. My next step is to get rid of this 2. And, excuse me, multiply row 2 times -2 and add it to row 1. And this is what I get. And at this point, I'm basically I know what the inverse of this matrix is, which is going to be this. So let me write it the following way. The inverse is, we use, in this case, if we call this matrix A, the inverse is represented by A, and then this to the -1 power, and this is your matrix, the inverse matrix. And I just want you to keep this in mind. When you multiply any matrix times its inverse, you get the identity matrix. And it would be good review for you, or good practice for you to multiply A times A inverse and A inverse times A, and you should be getting the identity matrix. Let's move on to number 2. So basically we're going to do the same steps as we're going to use the same process as number 1. I'll write the matrix there, excuse me, and then right next to it, the identity matrix. So my goal is to make this a 0, this a 1, and clean this up. So this will be the identity matrix on the left hand side, and something will happen here on the right hand side. So this is what I do. To get rid of this 3 and this -1, I do this. You should be able to follow. This is what I get. Now at this point, I'm going to work with this. I'm going to get rid of this -2 and this +2. So I multiply. I do the following row operations. And once I simplify, this is what I get. I'm almost there. So now all I need to do is get rid of these here, make these into zeros. So I perform the following row operations. And this is what I have. I have the identity. On the right hand side, I have the inverse. So if I'm calling this A, the inverse is equal to that, what you see here. Let's move on to the next slide. This is a little bit different. There's another way that you can find the inverse of a 2 by 2 matrix, and this is how you do it. This is the formula. It says use the formula to find the inverse of a 2 by 2 matrix, and given any matrix, the way that you find the inverse is you follow this formula that you see here. Notice that all we're doing is we're multiplying these two, and I'm taking the difference of those two products. This becomes the denominator. On top you have a 1 as the numerator, and then notice what happens with the matrices. You basically switch these two, and then you just negate these entries, the B and the C. Okay, so here we go. I apply the formula on number 3, and this is what I get. Substitute the values into the formula, and this is what I have. At this point, all I'm going to do is I'm just going to clean it up a little bit. This becomes 80. This basically stays the same. I can also write this answer the following way. I can distribute this scalar into the entries, and this is what I get. Both of them are correct. Either one works. Now, let me just, you're going to see this on the next section, but let me just highlight it here. This number here, 80, is basically the determinant of this 2 by 2 matrix. Excuse me. You're going to see, like I said, you're going to see this again on the next video. Let's move on to the next slide. So we apply the formula for number 4. So I just substitute the values. This is what I get. At this point, once I distribute, I get this. Either one is correct. You can give me the one on the left-hand side or the right-hand side. And again, if I ask you to compute the determinant of 4, which you will be doing this on the next video, on section 7.8, all you need to do is just focus on performing this operation here. Here's number 5. It says use the given inverse matrix to solve the linear system of equations. So this is the linear system you need to solve, and you want to use the inverse. Excuse me. So every single one of you should know how to come up with this inverse, either using the process that you saw in problem number 1 or 2, or the process they use on 3 and 4, which is the formula. So first thing you do is you write this augmented matrix and system as an augmented matrix, and this is equivalent to the following. You can write it as an equation. This matrix on the left hand side, 2 by 2, equals this other matrix on the right hand side. And then at this point, you're going to multiply this equation by the inverse. In other words, you want to do this. And at this point, when you multiply the inverse times this, the inverse of this augmented 2 by 2 matrix, excuse me, you're going to get the identity. Here, you're going to get the following, which means that the solution to this problem number 5 is x equals 6, y equals 3. Let's move on to number 6. Very similar to number 5. You want to solve this system using the inverse. At this point, what you want to do is write the augmented matrix of this system. This is what you have. So now I'm going to multiply this matrix. Technically, there's 2 matrices here. Just like on the previous problem number 5, you can break it up the following way. And you multiply this equation by the inverse, both sides, the following way. At this point, you should know that this gives you the identity, and this is going to give you your answer. So that's why your solution is 1, 7, negative 9. Let's move on to the last one. This one's a little bit different. It says use the calculator to find the inverse matrix and solve the system of linear equations. So there's number 7. You can actually find the inverse just the way that you did number 3 and 4. Excuse me, I take it back. Number 1 and 2, but it's going to be a time-consuming process. So that's why you want to use a calculator this time. And this is what you get once you use the calculator. I'm going to go very quickly through this, but I can clarify this in class. Just come and talk to me, and I'll be more than happy to tell you how we can get the inverse. But this is basically what you need to do using the TI-84. You need to go to the matrix key on the calculator, then go to the edit key. Once you have something on the screen, highlight the edit key, I'm sorry, and then you want to enter the order of the matrix, and basically you want to be looking at this matrix, the matrix generated by the just variables. So this 4x4 matrix, so that's the order that you want to enter at this point. Then you want to, skip this for a second. Once you enter the order 4x4, then you want to enter all the entries. The entries for the 4x4 matrix will be 1, -2, -1, -2. Forget about the variable. Go to this next row, 3, -5, -2, -3, and so forth. And once you have this 4x4 matrix, you want to do here. I clicked to zoom. You want to quit that matrix key on the calculator. Once you do that, you want to go back to it again. So hit the matrix key, and then hit the enter key, and then you should have the matrix that you just entered on your calculator, which is it should be matrix A. And then at this point, all you're going to do is, on this screen, you're going to raise that matrix to the -1 power. And once you do that, you should hit the enter key, and then once you do that, you're going to get, I click to zoom again, you're going to get this on the screen. And again, I can clarify this process. Just come and see me in class. Anyway, so now from here, what you're going to do is you're going to multiply this inverse matrix times this augmented matrix of this linear system, and you're going to go through the math, and you're going to end up with this, which means that this is the answer to your linear system using the inverse matrix. This concludes the video.